Let's take a look at how to find the domain of a rational function. So we talked about the functions 1 over x and 1 over x squared. The only value those exclude from the domain is the value x equals 0. Well, now we're going to get into just general rational functions and how to find their domain. So a rational function is simply a function of the form r of x, which is equal to p of x over q of x, where p and q are polynomial functions and q cannot equal 0, because recall that division by 0 is undefined, so we cannot have 0 in the denominator of a fraction. So that tells us that the domain of a rational function r of x is a set of all real numbers except those values that make q of x equal 0, or we could say that except for the zeros of q of x, to use the terminology from polynomial functions. So that is, we must exclude from the domain of r of x those values that make the denominator 0. So let's just go through these three examples and talk about what the domain of those functions would be. So understand that a rational function is just a polynomial divided by a polynomial. So the domain is going to be all real numbers except for where the denominator is 0. So for this first function, 3x minus 4 divided by x plus 2, we have to find the zeros of the denominator. Well, we know that x plus 2 is equal to 0 when x is equal to negative 2. So the domain is all reals except that value negative 2. So we would write that as negative infinity to negative 2 union negative 2 to infinity. Now what about the second problem, f of x equals 1 minus x over x? Here we have to find what number makes the denominator 0, and we know that x is equal to 0 at 0. So the only restriction from our domain is that we cannot have 0 in the denominator. So that domain would be written as negative infinity to 0 union 0 to infinity. Now you might be thinking about the range. We're actually going to talk more about the range when we get into the next section, which is on graphing rational functions. The last example, f of x equals x squared plus 1 over x squared minus 2x minus 8. So to determine the domain of this function, we have to find the zeros of that polynomial function x squared minus 2x minus 8. So we can factor this. The factors of 8, whose difference is 2, would be 4 and 2, with the larger factor being negative. So that tells us that we have zeros at 4 and also at negative 2. So the way we write this domain is we have to exclude both the negative 2 and the 4. So that would be written as negative infinity to negative 2 union negative 2 to 4 union 4 to infinity. So think about two holes in the number line. If you think about all real numbers, take out those two values. Everything else has to be in the domain. Okay? Now you can actually confirm this on the calculator, and let me show you that for just a moment. Okay, so I've pulled up my calculator and I want to look at the function 3x minus 4 of x plus 2. And so on the calculator, if I enter that function, and I have to be careful to enter the numerator and denominator in parentheses. So I have 3x minus 4 in parentheses divided by x plus 2 in parentheses. Now you could certainly graph. The graph may not mean a whole lot to you right now, but let's look at the table. And we're trying to show that x equals negative 2 is excluded from the domain. And you see what happens at negative 2? We get an error message because we are dividing by 0. So that confirms the fact that negative 2 should not be in the domain of that function. We could do the same thing for the others. Let me do that last example just because it's more complicated. So if I enter x squared plus 1 and then divided by, in parentheses, x squared minus 2x minus 8, and go to the table. So second graph, So I'm looking to find what's happening at 4 and negative 2. So here is at negative 2, I have that error message. And then at 4, I also get an error message. So that confirms that 4 and negative 2 should be excluded from my domain. So if you have any questions about how to find the domain of a rational function, please contact me.